Okay, question 7 is another circle theorem question, but it's got a couple combined. First thing we've got to do is work out the size of angle BAD. So BAD is that angle there. And to do that, if we look at the overall outer shape, we can see we've got a cyclic quadrilateral there. Sorry, drawn over it terribly. But we know it's a cyclic quadrilateral because all 4 vertices touch the circumference of the circle. And when that happens, the opposite angles add to 180. So this one must be 74 degrees. And it's not enough just to say it's a cyclic quadrilateral, we have to say what's special about that. So we have to say opposite angles in a cyclic quadrilateral add or sum to 180. Okay, BDO, angle DBO, that's that angle there. Now for this one, we're going to have to use another circle theorem, and it's the angle at the centre is twice the angle at the circumference. So the angle here is twice the angle at D, so we've got 114 degrees. And this is an isosceles triangle, triangle AOB. So 114 from 180 leaves 66, so each of these must be 33. And to find this angle, we're going to have to take away 157 and 74 that we found earlier from 180, because we know this is the remaining angle in the triangle. So we don't necessarily need to show this. Oops. Okay, now on the calculator. So that leaves 49, and subtracting 33 from that leaves 16 degrees. Okay, question 8 is quite a tricky question, and we're going to have to use algebra to solve this one. It's not a proof of a circle theorem or anything like that, but it is something we have to give reasons for, and it's quite a tricky question. Now the key to this question lies in the fact that there's a missing clue here. We're told that this is an isosceles triangle down the bottom end, so we know this is also x. But what we're not told, but we should still be able to work out, is that this is also an equilateral triangle, OC. We don't have another letter, so let's just label this D. For some reason D seems to have been missed out, maybe it should have been there. And that triangle ODC is also an isosceles triangle because we've got 2 radii. Okay, so let's come up with some expressions for the other angles. We'll come back to the reasons in a minute. If this angle is x and this angle is x, then we know this one must be 180 minus 2x. Okay, let's start there with our reasons. So let's say angle OCE equals 180 minus 2x, and the reason for that is that base angles in an isosceles are equal. Isosceles triangles are equal, sorry. And angles in a triangle add to 180. I'm going to put sum to 180 instead. Okay, right, now this angle here is going to be 180 take away 180 minus 2x, because it's on a straight line. Now when we do 180 minus 180 minus 2x, the 180s are going to cancel out, but we're going to end up taking away negative 2x, which gives us positive 2x. And that makes sense, actually. If this one is 180 minus 2x, we know the other one must have been 2x. And if that angle is 2x, then this one is also 2x. Okay, because that was an isosceles triangle. So we're going to say angle ODC is 2x. Again, before we do that, actually, let's talk about angle OCD being 2x, because angles on a straight line add to 180. Okay, and then angle ODC is 2x, because base angles in an isosceles triangle. Are equal. Okay. Right, and we need to somehow talk about this angle that we've been given, 69, to solve this. So let's think about the remaining angle in this triangle down here that we haven't given an expression for. This one would be 180 minus 69 minus x. Okay, so which simplifies to 111 minus x. And now we can use the fact that we know all of those angles add to 180 to solve this. Let's first write down what we've just found there. So angle DOC is 111 minus x, because angles on a straight line. Right. Now we know that 111 minus x plus 2x plus another 2x are going to equal 180. So altogether there we've got 111 plus 3x is 180. So 3x equals 69, so x is 23. So, and the reason for this was angles in a triangle add to 180. There we go. Tricky question. But the key to it lay in finding an expression for this angle, given that that was a straight line, and also knowing that it plus these other two would add up to make 180 because of the triangle. We've used two different facts there for that same angle to work out what it was, work out